I'm ready. Are you guys waiting on me?
No, I've been.
I don't know who we're waiting on.
I've been.
Let's get it rolling then.
Mary, you're first.
Oh, I am first. So I figured the calculation for the test statistic is 1.155.
1.155. That's. Hang on a second. Let me look at this.
Okay. Gosh, you guys, I'm so lame. Oh, we're on lesson 13. No, we're on lesson 12. Oh my goodness. What was wrong with me? Sorry. It's gonna take me a second.
You're okay.
How'd you get 1.155? I got 2.
Okay, so I have t equals d minus 0 divided by sd divided by the square root of n.
Yeah.
And so that's 2.2 divided by 3.3 divided by 3. And that gave me a grand total of 1.1547, which gives me 1.155.
Shouldn't it be 2.2 over 1.1, which is 2, shouldn't it?
No. I plugged it into my lovely graphing calculator, and I've got 2.2 divided by 3.3 divided by the square root of 3. And it gave me 1.154.7.005.
Are you throwing a parenthesis in there, Sarah? The 3.3 divided by 3 is...
Yep, it's all parentheses out. I can do it again. Make sure it's still better.
Yeah,
Well,
I got
2 as well.
And I got 2. Are you getting 2 as well, Mac?
Yeah.
1.1. Okay, so here you go. So here's the problem I'm running into is, are you guys doing the full thing, or are you guys just... Okay, let me try this again. 2.2 divided by, taking the square root. Okay. 2. What's the F? Hold on. Now I just got 2.2, which doesn't make any sense. Oh, that's because I did that wrong. Give me a second. Okay, I got 2 again. I don't know why I don't know why I did wrong. I actually cleared it out, so it doesn't matter. It's 2. You're right.
Okay.
Okay. Good. As long as we're all there, that's all that matters.
Oh yeah, you're good.
Okay, I'm way behind here. So, we got 2 for question 3.
It's 2 for question 3.
Okay. And somebody else take 4, and I'll try and catch up. I just got my right things open. Now I'm ready to read. So if somebody else can do 4, I'll hop in there on the next rotation.
Okay, use the probability of obtaining a test statistic greater than Jordan's test statistic of 0.03. Use the probability to determine the p-value for Jordan's hypothesis test. I'm not entirely sure what to do with these numbers.
Okay, so the hypothesis test is two-tailed. And so this is the step to the right of the upper T number. So if you think about it, we need to highlight, if we did this on the student T probability, we'd highlight the two ends, right?
How do you know
But
that
so
it's
they-
two-tailed, Sarah?
What?
How do you know that it's two-tailed?
Because it's a does not equal.
Okay.
Yeah, we're dealing with an equal sign.
Yeah.
Okay.
So because of that, what they gave us is they gave us the probability of the first tail, which means we just need to double it and we'll get the probability for both of them.
Okay, so it's just hang on a second, I scrolled away from it. So it's just 0.0806.
But we want
0.801. 0.081.
yeah, 0.081.
How many degrees of freedom do we put on that bad boy?
We don't know that. What we don't need, so you don't actually use the test statistic. So the 0.043 is the top half of it. Does that make sense?
Oh, okay. So it's, oh, sorry. I was trying to calculate it, and it's saying that it gave it.
Okay, I'm picking up what you're putting down now. Okay, since it's, yeah, so it's the probability of obtaining a test statistic greater. So we're looking at the greater than side right now. We're trying to find both the greater and the low. Yeah, okay, I got it.
Okay.
Which got us
What I got there.
0.0. Is that what you said?
0.081. Big helper, thank you.
And okay. Okay, I'm catching up.
No, you're okay.
I'll take 5 here.
Hang on a second, my Excel's
The
totally
next 6
frozen.
questions. Let me put this data in from A.
So first we calculate the difference, right?
What?
First we have to calculate the difference for this. Oh my gosh.
Yeah,
I'm having so many technical difficulties with my computer today.
You're fine.
I cannot even get Excel to respond. This has been happening all morning.
All right, I've got the test statistic to be negative 0.407.
Hold on a second. How do you read something? I make something wrong.
So Matt, will you just walk me through slowly, step by step, what you did? Because I'm not able to get my Excel to work. Or maybe
I'll walk you through, but there's not much I can walk through. I plugged it in and read the answer.
Right.
So,
you
what was? Oh, sorry.
No, that's okay. So you go to your chapter 12 data, you compute the difference between the two columns, right? And then you
Yep,
plug
I
in
copied over. Yeah, so I copied over group 2 and group 1.
Uh-huh.
Now, from the video I was watching, it seemed like group 2 is always the variable 1 since we're finding the difference.
Mm-hmm.
Is everyone else? And I was unsure of that one, so I was going to ask you guys actually. But group 2 I put for variable 1, and group 1 I put for variable 2,
Hold on.
which gave us the difference.
So is it not just a simple copy and paste over?
Yeah,
That's what I did.
Well, yeah. So copy and paste over, But for your variable one, is that group 1 or group 2?
Oh, it told us what to do in the assignment here.
Yeah, you just go, so if you stay on the chapter 12 data sheet, you go to column C, and you write difference, and then you calculate it, the difference into that column C, and you copy and paste column C
What?
into the quantitative inference
What the hell?
second tab where it says difference.
Make your group. Okay, so guys, pause. So it says make sure that test group 1 minus test group 2.
Yeah.
Yeah.
So if we're doing that, test group 1 minus. So we need to put test group.
Minus B.
So Mac is right. We need to put test group 2 into column 1 and test group 1 into column 2.
Yes.
That's ridiculous.
I
Quantitative procedure signal unknown. I put post at the top of 1 and free at the top of 2, just to remind myself to flip those.
Okay, hold on.
All right. So group 1 goes into column B.
Yes.
Correct.
Good catch, Matt.
Okay. I'm so totally lost. Give me a second here.
Okay. Yeah.
Is
Is your Excel up there, Becky? And you can, if you get your Excel up, you'll see it a lot easier.
I pulled it up, but I think I'm doing this way different than you guys are.
You have your data 12 data A open?
Yeah. So,
Okay, so you see group 2 that starts with 234.
yeah. So I go and I calculate the difference in column C in my group A data.
No, copy that whole entire column of group 2. Just copy that however it is. You don't have to do any calculation. It does it for you.
Okay.
Yeah.
So copy that whole column
Uh-huh.
and put it in variable 1 column. So copy it and then paste it in variable 1.
On the paired sample t-test for means?
Correct. Yep, exactly. And then go back to your 12 data A and copy group 1
Okay.
and post it on variable 2.
Okay.
And then type of test, make sure it's not equal. It doesn't change for t-test, but it will change our p.
Okay, 1 second.
And then it calculates everything for you. You don't have to pull out a calculator for these.
Okay, 1 second, I'm still.
Does that make sense?
Wait, I'm going to calculate the difference. The first difference I have is 32.1.
Yes.
Tell me the next step after pasting the second column, then what do I do?
And then just look at it. It calculates everything for you.
Okay.
And we got the test statistic as negative 0.407, right?
Correct. Yep, that's what I've got at least.
And 0.407. Okay. If you hold my hand, I can get the same answer as you. So thank you.
Sure. Is that making sense? Or-
Yeah, I was just doing that on. Yep. I was doing that on. Thank you.
Sure.
Okay, can I take 6? That's easy. The p-value is 0.344.
Make sure your type of test is not equal to.
Type of test is not equal to. So the p-value is 0.689.
Hang on. I've been totally kind of stuck and lost in.
Where are you stuck, Mark?
what to do here.
Mac's better at explaining it than I am.
So you've got the data open, right? 12A. And since we're finding the difference, we need to be post minus pre. And so far as they've given us this data, group 2 is post, group 1 is pre. So group 2, you're going to copy and then paste into variable 1.
The internet thing really stupid.
Say it again, Mac. So far, group 1 has been pre and group 2 has been post.
Group 2, yes. No,
What's the answer to number 5? Is that -7?
Mark, you broke up a little bit, but negative 0.407. Is that what you said?
7?
Yeah, negative 0.407.
Hear me?
Kind of. You're breaking up, Mark.
Hello?
There you go.
Hey, what's the answer?
Mark, I put it on
Answer to
the group chat just in case you can't hear us.
number 5.
Group chat.
Hey.
Look at the group chat, Mark.
Okay, I see it.
And then number 7, is everyone okay to move on to 7?
Yeah. You good?
Yeah. Is it my turn?
Sure.
What?
Go ahead.
Yeah, go see.
Okay. We failed to reject the null hypothesis because about the p-value is about 0.1.
Correct.
Yep.
You good with that? You good with that, Mark?
Yeah, I can't get anything in.
Mm. Yeah.
Becky, do you want to take 8 there?
Okay. 8. Suppose your alternative hypothesis is that. What is the correct decision based on this evidence? I'm saying C. We have sufficient evidence that the mean of the differences is greater than 0.
That's what I got.
Right, so the p-value is 0.689. We want to type in the answers for Mark on 7. He doesn't seem to be hearing anything.
Hi. What the heck is that all about?
I'll take number 9 here. So we did the same thing as the last one. And looking at them, N is 22, DF is 21, so N is obviously greater. Is that okay with everyone?
Just a second. I want to see if I can get the same answer. So the difference is 20, you said?
Number 9, N has the greater number.
Because N
So
is 20 and DF is 19.
If you switch over to data set B, Becky,
I thought I did.
So you have to delete all those columns and then copy over
Yeah.
data set B.
And try it again. I thought that's what I did, but
And remember, you're putting group 2 on variable 1.
2 in pre. Okay, so yeah, my differences are negative 39, negative 22. Is that right? But the
Say that
end,
again.
the end that I get is still 20, and my DF is still 19.
Can you guys hear me?
What's that?
so
Now we can, Mark.
Okay. Isn't DF like way bigger than N?
No, DF is what do you call it? It's that one thing where you do n minus 1. So n will always be bigger than DF.
Oh. What's the DF in the spreadsheet then?
Degrees of freedom.
Thank you. I couldn't
Oh,
remember.
okay.
Like it's that one thing that we love and adore.
What type of test are we doing here? Greater than, less than, not equal to?
Greater than. Yeah. We should. Our n should equal 22, correct?
And I'm so lost.
Hold on. I have a child who's protesting.
T-test for means, right? Paired sample t-test.
Yeah, paired sample t-test. And our n.
And for pre, post, and difference, right? So I thought n was just the sample size.
N is the sample size. I've got 22 for my sample size. I thought somebody was telling me I had 20.
Yeah, that's weird because my pre-sample size is 22, my post is 22, and the difference is 20.
I've got differences equals 22. Becky, it should equal the same.
Yeah, it should be the same. I'm missing 2 solutions over here in my third column.
So what happened, I think, when you try to enter this data in by hand in the last one, I think you took out the formula.
You're right.
And so if you just click one of the ones that has the formula in it and hit Control-C and put it back in, it'll re-put the formula in for you.
Okay. The next tab has the okay.
Did we get the p-value to be 0.001?
Yes.
Yeah, that's what I got as well.
Oh, hey, real quick. Are we sure that that number 8 is greater than? I thought they were testing not equals to.
What?
Are we sure that number 8 is greater than? I thought they were testing not equal to.
Yeah, it's not equal to. It's not equal to. It's
So,
well, we had a question 12 that brings up greater than again, but we're still on not equal to.
well then how is number 8 C?
Number 8, sweet. Oh no, I have number 8 is we have insufficient evidence of the mean of difference is greater than 0. So B as in Bravo.
Okay.
Going back. Okay, so and 0.001. Are we ready for question 11?
I think so.
Okay, who is that? Mark? Is that one mine?
I can take it. I've been kind of MIA, but I don't. So the p-value is technically slightly higher than than alpha.
Alpha. Oh, that's true. Value reject. Good cat. Wait, no, it's not. No, because the p-value is 0.001, so it's going to be less than the alpha.
Oh, I'm sorry. Yeah, you're correct. So yeah, we reject the null hypothesis.
Perfect.
I'll take 12 here, just kind of follow along. So right now it's not equal to. If we change it to greater than, it goes up. I'm going to say 12 is increased. Is that correct?
That sounds correct. I'll take 13. We failed to reject the null hypothesis.
Okay, it's me that I'm totally behind based on what conclusion to make. So let's see. If we fail to reject the null hypothesis, that means that we have insufficient evidence.
Oh, you know what, guys? Sorry, on 12, I let us astray. 12, I think, should be decreased because it went from 0.001 to 0.0006, so it actually got smaller.
I got a different thing on that from you.
Mine's my p-value is 0.999.
Yeah, that's my p-value is 0.9992.
So what did I do then?
That's a good question.
Oh, did you?
So
So if I put in less than, it's 0.999, but aren't we doing greater than?
Greater than I get 0.0999. Confidence level is 0.95. Null hypothesis is 0. Type of test is greater than.
Yeah, and mine comes up at 0.0006.
Hold on a second.
That's
Mark, what do you have on your p-value there?
For greater than, I have 0.999. What's your differences of mean? My differences of mean is negative 11.955.
Yeah, that's what mine is as well.
Mac?
My test statistic is negative 3.737.
Yeah, so is mine.
Okay. Mac, are you sure you copied the columns over right?
I'm just double checking that now because I've got different stuff here.
Yeah, you're good.
Sorry, no, I did not. Here I've been talking about it the whole time and I copied it wrong.
It's all good.
You're fine.
Exciting days for our group today, huh?
I know.
All right, now I'm at 0.999. Sorry.
You're okay. I just glad we double
So
checked it.
did.
Yeah.
Yep, thank you. All right. I just need to listen to myself.
Are we on question 14? We're on question 15.
Yeah.
So we failed to reject the null hypothesis in 13.
Yeah.
This means we have insufficient evidence that there is a mean difference between the two groups.
Yep. That's what I got.
Yes.
Say that one more time for 13. It cut out.
D.
Okay.
Even dog.
All right, and then question 15 is less than, correct?
Question 15 I have not equal to. Because that's what we started with. I might be incorrect. If it's not equal to, I'd say not enough information depends on the problem, but I think it's not equal to.
All right, hang on. Let me mess with my spreadsheet here.
Because the greater than or less than are always going to be the same p-value.
All right, I'm willing to buy that for $1.
By the not equal to? Okay. All right.
Wait, sorry, just real quick. When you do less than, You get 0.0006.
So we agree on not equal to?
Well, if you do on this last spreadsheet, if you do less than, it's
True.
smaller than not equal to.
Is it not
Oh,
information? Depends on the problem? Or is it less than? I think it depends on the problem, because I think it depends on the data set, wouldn't it?
Let's throw in a bigger data here and see.
I don't think it can be not enough information because it just says in general.
Yeah, I think I'm with Becky. I think it's not enough information. Depends on the problem.
I agree, because I
Okay.
just changed the data point and it threw off our previous, so not enough info.
Yep.
I don't know.
You're having a serious statistics question. Meanwhile, my daughter's like chewing on my thumb. I'm like, yes, very serious situation.
Yeah.
Okay, sorry.
You got all prune thumb going.
Last way, 15, the point estimator. What is the point estimator? Is that the t-statistic?
It's the sample mean of differences.
Sample mean of differences, so that is...
Is that 3.199?
Sample means of differences.
Negative 11.955?
Yeah, negative 11.955.
Oh, okay, yeah.
Okay, negative 11.955.
Sorry, my bad.
Let me get there again. Okay, so negative 11.955.
Yeah.
Fantastic. Margin of error.
How do you calculate the margin of error?
So that's in last week's thing. Swear words.
It's your confidence interval. So it's the t star, so our t value, times standard deviation over square root of n. Is that right?
So is that the same all the time for 95%? Is that the 1.965?
Yeah. X. Alright, so negative 18. Okay.
I got a negative 11.953.
Hold on. I don't think that's right. I might be wrong. Give me a minute.
It probably isn't.
What did you get for your S, your standard deviation? Is that the
That's the
3?
SD.
Isn't standard deviation 15.003?
Oh.
Sample standard deviation of differences. 15.003.
15.003.
All right, let's see here.
I've got 6.652.
I think I got
Okay,
Mark. What Mark got? Negative 11.931.
That's what I got. Or
How you
I got
guys?
negative 11.953.
Oh gosh.
I've got 6.652.
Okay, hang on. So the t value, the t we're working with is negative 3.737.
Yeah, hold
Is
on,
that
give me a
correct?
second. Let me find something really quick. Okay, great.
Like, tell me the numbers and where they're getting them from. Like, where do we get that? Where are you getting that value from?
Just from the table.
And it is what?
Negative 3.737.
Standard deviation is on the table as well. And it is what?
15.003.
Okay, that would be enough.
So then, Mark, did you do 15.003 divided by the square root of 22?
Yeah, that's what
And
I
then
did.
multiply that by negative 3.73. Is that what you did?
Yeah, that's what I did.
Hold on. Damn. Give me a second. Control F. Margin. Where the hell is it going? Margin? So here's what I did, and maybe I'm a horrible person for doing it this way, but so in theory, our come back to me, brain. You have our lower confidence thing, our upper confidence thing that the thing gives us, right? The confidence interval. I took, you know that the mean is negative 11.955, so that should be in the dead center. So I took, I did negative 11.955 minus equals negative 8.67, and 11.955 plus x equals negative 5.303, and that's where I got the 6.652. So it's the same on those.
Okay, so I see what you're doing here, but shouldn't you because you're finding the exact center between the confidence intervals, which should be right. But negative 6 point whatever is like way closer to your higher confidence interval. It should be negative negative 6 point whatever plus negative 5.303.
What? No, it's 6.652, and the margin of error tells us how far away it is. It should be basically, the margin of error should tell us, you add the margin of error from, okay. I feel like I need to be able to, okay, in order, actually I have an idea, How about we just go through the rest of it, and if I'm wrong, it'll come up that I'm wrong. If you're wrong, it'll come up you're wrong, and we'll go with whichever one was right.
Can't share answers like that.
What?
I'm joking.
No,
I'm
okay.
making a jab.
So let's run through the theory of the margin of error. It's the margin of error minus our mean is going to give us our lower bound. Margin of error plus our mean is going to give us our upper bound. So that's what I
did. Isn't there just an equation for margin of error?
What?
Isn't there just a simple equation for margin of error that you can plug in the numbers and go?
There is, but it's also sometimes it's easier to solve for x and just do a mean. But again, where's our formula for margin of error?
It is t star, so our t value, times the sample standard deviation divided by the square root of n.
But where's that? Wait.
Hang on. Are we trying to figure out the standard, the margin of error for the point estimate right now?
The standard deviation, not the standard deviation. The margin of error. Wait, give me that formula again, real quick, Mac.
T value times the standard deviation of differences over square root of n.
Hold on. Okay, hold on. T-value, T times square root of differences over n.
Sample standard deviation of differences over square root of n, yeah.
Okay. Where are we getting this? Where are you getting that from in the reading?
I got that from the videos that coincide with the reading.
Okay. But so the way I can always test. So what I have to give you? Okay, so that's t-value times st, and then t-value in total is divided by the square root of n, correct?
No, I apologize. So t-value times parentheses sample standard deviation over square root of n parentheses.
Okay, let me check it. All right, let me see where we're getting it from. Hold on, I know cute guys would. Okay, hold on. Okay. Okay. T-value. Well, because margin of error always has to be positive, right? So are we missing a squared on this somewhere? Matt, where's it supposed to be squared?
I don't have that answer for you.
Okay, hold on.
I just have that as the equation.
What do you think was your answer for that math, Matt? 1.05.
I got 11.931, negative 11.931.
You got negative 11.953.
So it's just positive, because you're right, the margin of error can't be negative, so it's just the absolute value of it.
But I thought, so in the earlier margin of error we did, in a different section, like they squared it to get it positive, they didn't do an absolute value on it. So that's, I feel like something's off, especially because the margin of error or minus is going to get our upper and lower bounds, and we already have our upper and lower bounds, and they do not match up with that answer.
Okay.
So I mean, you also want to put. I really do think it's the 6.52, and maybe I'm wrong and I'm way up eating my words. I think it's 6.62.
What? 652?
That's what I think is correct based on what our upper and lower bounds are. And I may have to see my words.
So then what are our lower bounds and upper bounds?
That's in the confidence interval that the paired t-test gives us. That's the only reason why I'm disagreeing with Mac on that.
Negative 18.687.
Negative 5.306. Max, that's the only reason I'm disagreeing with you, because that number does not work with bounds.
Okay, so you guys are going to 18 and 19, correct? 18 is 18.607 and 19 is what?
Negative 5.203.
You type it in for me, please. You're breaking up for me.
Negative 5.03.
Negative 5.03.
Negative 5.203. 3.
Well, you guys.
Yeah.
Hey, Mark, do you want to hit the live button for us? Take us off live, and I think you got it.
All right.